So here we go. We're going to start by doing an outline of the four-step process with an example that we looked at before, which is our battery life example. Company claiming to developing a new battery that lasts longer, so they want to have this idea that the batteries might last longer than our standard 30 hours now. So, do we have convincing evidence? Our null hypothesis would be that the mean is 30. Our alternative would be that the mean is greater than 30. I know the alternative is that the mean is greater than 30 because I want the batteries to last longer. We talked about that first step. Now let's talk about the rest of the steps. We are going to test conditions. And our conditions are going to be random, normal, and independent. And the only difference between the means and proportions, we talked about this earlier, is that if we are talking about means, then instead of n times p and n times 1 minus p, we're just checking our sample size and checking if our sample size is at least 30. So in this case, the sample size is 15. Now when the sample size is smaller, again, we did this last chapter. When the sample size is smaller, that means we need to look at the distribution and see if we have enough, have any evidence to overturn using a normal distribution. If the sample size were bigger than 30, then we're done, and we don't need to worry about any of it. So we're going to look at some plots, and we're making sure that we're fairly symmetric with our distribution. In our, remember this was called a normal probability plot, and we're looking for this to be fairly linear. So box plot looks fairly symmetric. The normal probability plot is close to linear, so that's not enough evidence to overrule using a normal distribution. That's what we would do if sample size is less than 30. If the sample size is at least 30, then we can just say n is at least 30. And then our independent condition is the same as it always is. They make at least 150 new AAA batteries, 10 times sample size. Yeah, that seems reasonable. All right. The calculation. So we're going to write down the formula here. For means, remember our standard deviation formula for proportions was square root of p times 1 minus p over n. Our formula for standard deviation when we have means is sigma over square root of n. So that means that we need to plug that into the standard deviation part of the formula. Since we are using means instead of z-scores, we're going to be using t-scores again. So our t-score, value minus mean over standard deviation, or statistic minus parameter. The parameter we're trying to measure is the population mean. Of the null hypothesis. The statistic, the data that we get, is our sample mean. So the sample minus the population over what our standard deviation is, which is going to be standard deviation over square root of n, or sigma over square root of n, depending on what we're given. But this is going to be a t-score. And we're also going to be using, since we are using t-scores, we need to be thinking about degrees of freedom. So remember, degrees of freedom is our sample size minus 1. So that's our formula for the t-score. And again, degrees of freedom here is going to be n minus 1. Sample size minus 1. So really all we're doing here is we're taking what we already know about means from doing confidence intervals, and what we already know from hypothesis tests and our 4 steps for that, and we're kind of mashing them up together. That's really all we're doing. Nothing here that we're doing today or tomorrow, at our Zoom meeting tomorrow, nothing should be all that new or surprising or throwing something completely new at you. $11:30. I have on the calendar. I've posted the times of the Zoom meeting now. So, because I had some confusion yesterday over what time the meeting was, because it's at 11:30 on the Fridays, and then classes at 10:30 on the rest of the week. So yeah, still 11:30. That's going to be our usual Friday time. All right, moving on.
I think to decrease confusion, we should have every Zoom at 9 p.m. Just set it for a standard, 7 days a week, 9 p.m.
Rehearsals.
So at 10 p.m. Okay, I see what you're saying.
All right, there's the mean, there's standard deviation. We're going to put it into the t-score formula. We got our x bar being 33.9. What was our mean for the null hypothesis? It was that the mean was what? 30. That was what our null hypothesis said. So we're going to have 33.9 minus 30 over standard deviation over square root of n. What is our standard deviation part of the formula? So formula, plug in the numbers, answer. Then it's about to show you a whole bunch of stuff from the table that, unless you're planning to use the table for t-scores, you probably don't need to write down, because you're going to just have the calculator do it for you. The thing that you do need to write down is your degrees of freedom. What is your degrees of freedom here? 14. And you got that from 15 minus 1, sample size minus 1. So then we're going to use that t-score and the degrees of freedom of 14, and we are going to get our p-value. And guess what? The p-value, again, you don't need to write this down because we're going to write down a different concluding sentence. That's larger than 0.05, which means that we will end up failing to reject our null hypothesis. Our sentence is going to be the same sentence that we've been using this whole time. You're going to compare the p-value to the alpha level. You're going to say, that means we reject or fail to reject, and that will tell us whether or not we conclude the alternative. Same exact sentence. Again, the only thing you really need to write down here is that make sure you're using degrees of freedom of 14. And make sure you write down formula, plug in the numbers, answer. It's the only thing you strictly need to write down. The rest of it's going away in 10 seconds. Again, you'll have the video to look back on if you need to write anything else down. And then 2 whole slides about using the table that I'm going to skip. If you happen to be using the T-score table instead of using the calculator, then you can come talk to me and I'll help you out. But I think almost everyone is using the calculator to do this. All right, one sample t-test. That's what this is going to be called in the calculator. One sample. Notice it doesn't say proportion this time because we're not using proportions anymore. And then t-test, because we're doing a hypothesis test and not a confidence interval. So here comes your formula. You already wrote it down, but here it is again. And we're going to use degrees of freedom of n minus 1. And while you're getting that information down, one second.